This is geometry, 3.2b, talking about algebraic proofs and some properties. So today we're learning about the reflexive property. So what we want to recognize is if you have a figure that is sharing a side, we're going to have lots of these in the future. We're sharing a side that AB is in both triangles. There's going to be a point that we need to talk about how AB of the left triangle is the same as AB in the right triangle. They are equal to each other, and that's called the reflexive property of equality. It's clearly not the addition property of equality, but it's the reflexive property of equality. They are the same. You can also have reflexive property of equality for angles. If you have a triangle that has an angle B, and you also have another triangle that also has the measure of angle B, then both of those B's or both of those angles are congruent to each other. It's the same angle. That's called the reflexive property. If you're at the same location, not just two angles that are congruent to each other, but two angles that are each other, that are the same. That's the reflexive property of equality. So as you see over here, it's kind of silly. If you have a value of A, then you know that A has to equal A. It's going to be the same thing in any of the same problems. The value of A is going to be the same as the value of A. It's kind of a silly statement, but that's called the reflexive property of equality. Then we can come down to another property called the transitive property of equality. Now, typically for transitive property of equality, I would use substitution. Substitution will be used more here, and we use transitive later on when we're dealing with congruence, but it does have its own property. If you have AB, segment AB, and another segment CD, and a third segment EF, that's kind of your hint. This requires 3 bits of information. If AB is the same measurement as CD, and CD is the same measurement as EF, then you're going to know that the AB is the same measurement as the EF. Yesterday, we used the same pattern, but we said that if CD equals EF, then we can substitute that in. That was substitution property. And with equal signs, you're allowed to substitute. But we have another way we can do it called transitive property of equality. As long as we have this pattern, we can come up to the conclusion that your first term is going to equal your last term because both of those terms equal the same thing. So if A equals B and B equals C, then A equals C. You can also do it with angles. If I draw the same angle that you do, and I drew the same angle as your friend, then what could we say? If A equals B and A equals C, what else could we say? Then the measure of angle B is going to equal the measure of angle C. If B equals A and A equals C, then B equals C. That's called the transitive property of equality. Here we're going to be talking about the transitive property. Now notice what they're doing here. They're using POE. That is a shortcut for property of equality. Not my favorite thing. I really prefer you to write it out, but it's okay from now going forward for you to use POE for a shortcut for property of equality. You need to write out the first word completely. Maybe it's addition property of equality or transitive property of equality, even subtraction property of equality. You can use POE for that whole property of equality. But you need to know what POE stands for. So know what you're talking about. Property of equality. So we're supposed to be representing property of equality, or transitive property of equality. So if R equals S and S equals 44, then what could we say using this property? Since we know that S equals R, and we also know that S equals 44, I know that R is going to equal 44. You need to be observant. You need to look at what's there. This is really a silly one. It seems so simple. It's going to be used in your proofs in the future. Reflexive property of equality. Reflexive is like a mirror. It's the same thing on both sides. So if we say that we have the measure of angle n, what would that have to equal if we were using the reflexive property? The measure of angle n. It has to equal itself. It's got to be the same on both sides of the equal sign. That's the reflexive property of equality. Here's the addition property of equality. Here we're adding the same amount to something. The same value must be added for this to be the addition property of equality. What are we adding xy to, and what else are we adding xy to keep our equal sign the same as what we had earlier? Since we know that RS equals TV, then if you add XY to RS and you add XY to TV, then you're making an equivalence, something else that was equal, using the addition property of equality. And then last one, this is the one that gets a little tricky understanding what to do. This isn't an equal sign like equals 14 or anything like that. But here we're going to use what's considered the substitution property of equality. The measure of angle 1 is 20 degrees. We know that. That's supposed to be a fact. The measure of angle 1 plus the measure of angle 2 is going to be talked about now. What can we say as a new statement that would be supported using substitution? We're going to use substitution, so we have to substitute something. I know that the measure of angle 1 equals 20, and I know that the measure of angle 1 is being added to the measure of angle 2. So what is a new statement that we can say? Here we have the measure of angle 1 is 20. Here's the measure of angle 1. So we're going to substitute that value in for the measure of angle 1. And now we know that 20 plus the measure of angle 2. Now typically we'd have more to talk about. That's going to equal something, and then we can go ahead and do the algebra. But that's the substitution. That's plugging in your 20 for an expression.